So this video is on our notes for law of sines. And this is going to be dealing with triangles that are not right triangles. Up to this point, all of our triangles, we're going to focus on this part of the notes to start with. All of our triangles have been right triangles. And in this situation, these are not right triangles. So these formulas, I'm not proving them for us right now. We're going to be using them, and tomorrow we're going to be learning about law of cosines. So what's going to happen in this is I'm going to kind of color code things. When you have a situation like this, and you have an angle A, the side across from it is going to be little a. Okay. If you have angle B, the side across from it is going to be called little b. And if we have angle C, the side across from that is going to be little c. Now, what needs to happen is you're going to need to know one of these pairs. You either are going to need to know your, let me just kind of circle this, your angle A and side A, or you're going to need angle B and side B, or you're going to need angle C or side C. You need to know one of those pairs in order to use law of sine formulas. Now, you'll notice up here, I have angle, side, angle, and angle, angle, side. So these situations are going to be where I know two angles, and I either know the side in between or the side that's not in between. And so we're going to do one of each of these. Now, the formula is the following. And we're only doing a pair of these, not all three of these. Okay. So if I know sine A over A, then I can set that equal to sine of angle B over B. Or maybe I am going to set it equal to sine of C over C, any combination of these. Okay, any combinations of these. And actually here, let me match my colors. So this was my B, this was my C. Okay, so that's what we're going to do. So on this first one, in terms of looking at it, this is an angle, this is a side, this is an angle. So this would be angle, side, angle. That's the relationship I have here. Okay. Now, the nice thing about angle, side, angle, or angle, angle, side, is that if I know two angles in a triangle, I can always find the third angle. So let me first just kind of label things, okay? So in this situation, this angle R, I can find it because I can use the fact about the other two to find it, but that goes across with this, so that is side R, that's 6.3. This angle P here, okay, this angle P here, that's going to go across, and that means that this is going to be little p. And this angle Q here, which is 51.2, across from it is going to be little q, okay, in terms of what we have. Now, looking at this so far, if I look at my purple, I don't know my angle, but I know the side is 6.3 across. If I look at my pink, I know my angle 63.5, but I don't know the side across. If I look at my orange, I know my angle Q is 51.2, but I don't know the side across. So I don't have any pair, but I can easily get my purple angle because I know that in a triangle, so this is going to give me my R, okay? In a triangle, if I take 180 minus 63.5 minus 51.2, that is going to give me my angle. And let me just get that math going here. So 180 minus 63.5 minus 51.2 is 65.3. So that's going to be 65.3 degrees. So I'm just going to write that in here. So I am going to get, this angle here is 65.3 degrees. So now I know that purple pair. I know the angle and I know the side opposite. So that's what I'm going to use to help me find my side P, which is my pinks, and my side Q, which is my orange. Okay. So for this, I'm going to set up, and I'm just going to kind of color code. So I'm going to do sine of 65.3 over the side opposite it, which is 6.3, equals, and let me do my P first, okay? So angle P, so that's going to be sine of 63.5 degrees over little p. I'm going to cross multiply and solve. So when I cross multiply, I'm going to get P times sine of 65.3 is equal to 6.3 times sine of 63.5. I am going to divide both sides by sine of 65.3. So I'm going to get P equals 6.3 sine of 63.5 over sine of 65.3. So now I'm going to put that into my calculator, and I want to make sure that my calculator is in degrees when I'm dealing with triangles. So I am going to do alpha and y equal, and that gives me these options, and I'm just going to hit enter. I want number 1. That's going to give me fractions, and then I'm just going to type this in. Okay, so I'm going to type in 6.3. Let me zoom in a little bit more. 6.3 sine of 63.5 over sine of 65.3. And I'm going to end up getting, let's give one number after the decimal, so about a 6.2. So this is going to be 6.2. That's my side P. I'm going to go through the same process for side Q. So let me set that one up. Okay. So here, I'm just going to do this. So this was me trying to find my R. This was me trying to find my little p. Now I'm going to find little q. Okay. So I'm going to start with what I know again. I knew the sine of 65.3 over 6.3 is equal to, and now I'm going to do my orange. So I'm going to take sine of 51.2, which is angle Q, over the side opposite it, which is little q. Cross multiply and solve. So I'm going to get Q times sine of 65.3 is equal to 6.3 sine of 51.2. I am going to divide by sine of 65.3. So I'm going to get 6.3 sine of 51.2 divided by sine of 65.3. Put that in my calculator. Now, what I'm going to do is I am actually going to do second and enter. It's going to retype in what I just had. And what you'll notice is I have the 6.3 in both of these. I have a sine of 65.3 on the bottom. This needs to be a 51.2. So all I need to do is come up here and change this to 51.2. And then I get my answer, which is 5.4. And so that is my side Q. Okay, this next example is an angle side. So you'll notice that I have this angle, I have this angle, and I don't have the side in between. That would have been angle side angle. I have the side outside of that. Okay, so that's angle side. But again, if I have two angles, I can always find the third. So finding C will be my easy part of this. Okay. So let me just kind of match things up. In this case, I know this angle A is 40 and I know the side opposite it. So that's the pair I'm going to use. If you know a pair like this, you can use law of sines. Okay. If you don't know a pair and can't get a pair because of maybe angle situation, you could always find that third angle. But if you don't have that, we're going to probably use law of cosines. We'll see that tomorrow. Okay. So I've got my 60 degrees, which is angle B. So this is going to be little b. And I have my, well, I think we can figure out that this is going to be 80 degrees. Okay, because together the other two are 100. So 180 minus 100 is 80. Okay, so I know this angle C now, and I need to find little c. Okay, so right now I just found that C is 180 degrees. Okay, so I know that. So now I just need to find little c and little b. Okay, so I'm going to use my angle A and side A because I know those. So I'm going to do sine of 40 degrees over 4 is equal to, and let's find B first. So sine of 60 degrees over little b, cross multiply and solve. So when I cross multiply, I'm going to get b times sine of 40 degrees equals 4 sine of 60 degrees. I'm going to divide both sides by sine of 40 degrees. I'm going to put this in my calculator and get my answer. So for that, okay, I am going to have 4 sine of 60 over sine of 40. And I end up with 5.4. Let's give one number after the decimal. So 5.4 for side B. Going to do the same process for finding little c. So again, start with the one you know. And here, let me just kind of separate it. Okay, so start with what you know. So I knew sine of 40 degrees over 4 equals, and now I'm going to do my c, so that's going to be my orange. So I'm going to do sine of 80 degrees over c, cross multiply and solve. So c sine of 40 degrees equals 4 sine of 80 degrees. Divide both sides by sine of 40. So 4 sine of 80 degrees divided by sine of 40 degrees. I'm going to put that in my calculator. Now, again, you'll notice that it's almost the same, except for that 60 needs to now become an 80. So I'm going to hit second and enter. And then I am just going to come up here and change this to an 80. And I get 6.1. And that's little c. Okay. Now, when we're doing these problems on the homework tonight, they're not going to say on all of them, find this angle, that side. Sometimes they're going to ask you for a particular piece of information, but most of the problems are going to say solve the triangle. And when it says solve the triangle, if I was doing this problem and I knew angle A, and I knew angle A, and I knew angle B, and I knew this side, I'm going to find all the missing sides and angles. So I'd have to find angle C, I'd have to find side B, and I'd have to find side C. So if they say solve the triangle, they mean find all of the missing pieces, all of the angles you weren't given, and all the sides you weren't given. Okay, so let's come to this one now. This one here is dealing with not angle side angle or angle side. In this case, I don't know two angles and a side, whether it's in between or not. I know two sides and an angle. This is called the ambiguous case. This is a situation that side angle, or ASS, is not a congruent relationship. We saw that in integrated one. We saw it earlier this year. I'm just going to click on this link. Sorry, I got to get, I'm going to click on this link. And hold on, let's see if it'll let me. Okay, and on this link, this is the ambiguous case. So what you'll notice here, let me just get so I can draw. Okay, so what you'll notice here is I have this angle, so that's my angle. I have this side and I have this side. They didn't give us the value, but that side is not changing, it's staying, okay? So that's angle side. Now, the reason that this is not congruent, okay, like a congruent triangle, is the following. If I was to take this side C, which is kind of pivoting right here, this angle can be adjusted. That angle is not set. The angle that's set is this angle over here. These two sides are set. These two sides are not changing, okay? But the angle that's joining them is not determined, okay? Like that 45 degrees is. And so what they're doing is they're shooting off a ray. They're shooting off a ray here that's going out forever and ever. So that 45 is between that ray and that one side that I know, that 4.11. And again, I still know that other side, it is a set length. They just didn't give us the value, but it is a set length. And then what's going to happen is, again, that angle was not determined. So if I move this, okay, I can come around this way and I get this little angle here. So in this case, my triangle you see is going to be that portion. And I'm going to have, this would be my angle length. But I could also have moved it, instead of going this way, maybe I swung it this way, and then it ends up hitting right here. And then you see I end up getting a bigger angle, okay? So there are two possible triangles here. One triangle would have been, let me get my purple. One triangle would have been this one here, okay? And the other triangle is this red one here now, okay, with that. So I could have that as a triangle, or I could have had this as a triangle. Both of them have that same side length that I was swinging, and both of them share that 4.11. The 45 degree is set, but the other angle is pivoting and it can change. So you can get more than one triangle. So that's what this ambiguous case is. So if you have a situation where you have side-side angle, you need to think about, you might have more than one possibility. Okay, so back to this situation, okay, the ambiguous case, side-side angle. Okay, so here's a visual kind of showing that. So again, you have this set angle here that is 48 degrees. Okay, that's set. You have this side here that is 20. That side is not changing, but what is going to be changed, and this side is going to be a 16. It's a 16 here and it's a 16 here. What's changing is this pivot right here. Okay, where they're connecting. That, think of it as a joint. And as I have those two sides that are predetermined, that side BC can hit the ray AC in different spots, okay, in different spots. And I can get two triangles, okay? So we're going to go through different situations. In all of these situations, we're going to have a set angle, 30 degrees. We're going to have a set side, which is 16, and we're going to have another set side. Okay. Now, in this situation, we have this set side, which is 10, but what's going to be adjusting is this angle up here. So you see, they have it where this could go all the way to here to form that bigger triangle, or that same side could have swung to here and hit that ray. And I would have had this smaller angle up there. So I could have two totally different triangles. That's what we have to be careful of. So what they want us to do in this is to find this angle B. We want to find that angle B. And that angle B, if you notice, is going to be different here than it is over here. Those are going to be two totally different angles. One looks like it's going to be more than 180. I mean, more than 90, I apologize. The other one is going to be less than 90. So you have to be careful. So on this situation, let me kind of clear all of my scribbles. Okay, so I'm going to match things up. And right now, kind of ignore this line here. Okay, pretend it's not there. Okay, it's the same A, that is 10. So what I'm going to do is what I know is I know this 30 degrees and I know this side of 10. Okay, I need to find B. I want to find this angle, don't know it, but I know the side opposite. So what we're going to do is the following. Okay, I'm going to set up a ratio. So I am going to do sine of 30 degrees over 10 equals sine of B. So this is a little different. I don't know my angle this time. I know my side, which is 16. Okay, cross multiply. So let me take 10 times sine of B equals 16 times sine of 30 degrees. I need to get my sine of B by itself. So I'm going to get 16 sine of 30 degrees over 10. Now, that's my sine. I don't want the sine. I want the angle that gave me that sine. So this is where those inverse trig situations come into play. So I am going to basically take the sine inverse of this. Okay, and I'm just going to put all that straight into my calculator. Again, making sure we're in degrees when we're dealing with these triangles. Okay. So to get sine inverse, I'm going to do hit second and sine. And then I'm going to put it in as a fraction. So I'm going to hit alpha y equal. And then I'm going to type in 16 sine 30 over 10. And sine 30 is a value we know, but let's just work it out because sometimes we may not know that value. I want you guys to understand how to do the calculations. I hit enter and I get, let's give one number after decimal, about a 53.1. So my angle B is going to be a 53.1 degrees. Now, if I'm looking at this picture here, okay, if I'm looking at this picture here, this B here that I just drew, that B here would not be the 53.1 visually looking at it. That 53.1 would be over here. So I need to find this other possibility. Now, to find the other possibility, what you're going to do is the following. Okay. So to find other possible B. You're going to basically find its supplement. You're going to go 180 minus 53.1 to see what we get. Okay. So I'm going to take 180 minus what I just got. And I get 126.9. So 126.9 degrees. Now, this is my other possible angle B, but we need to make sure it is possible. So what do I mean by that? Well, I have a triangle, okay? in my triangle, I know that this is 30. We're saying that this is 126.9. I need to make sure that that's reasonable. I need to make sure that those don't add up to more than 180, because if it adds up to 180, then I have nothing left for that third angle. Or if it adds up to more than 180, I've used up more than I have. So what you want to do is you want to make sure that that makes sense. So to check, what we're going to check is we're going to take 30 plus 126.9. Okay, and we want to make sure that that's less than 180 degrees. And it is, because I got 156.9. And that's going to be less than 180 degrees. So what does that mean? This one was an answer, which we already knew. But this is also another answer for B. Okay, so this one would have kind of given us that situation. This one would have given us this situation. Okay, on our next example. So again, you'll notice that I have the same 30 degrees I had before, but now the side opposite it is different. It's a 20 now. They still want me to find angle B, okay? And I know the side opposite it. So again, I have side, angle, ambiguous case, need to be careful. So let me first find my first B. So I'm going to take what I know, which is sine of 30 degrees over 20 is equal to sine of B over 16. I'm going to cross multiply. So I'm going to do the 20 sine B first equals 16 sine of 30 degrees. So sine of B is going to be equal to 16 sine of 30 degrees over 20. So now, again, I need to find the angle. So I need to do sine inverse. So I'm going to do sine inverse of this, of 16 sine 30 over 20. Okay, I'm going to put that into my calculator. So I'm going to do sine inverse of 16 sine 30 over 20. And I end up getting a 23 point, let's say 6. So B equals 23.6 degrees. Okay. So again, in this situation, that would have been here, but maybe this swings and it hits in a different spot. Okay, that's kind of what we're looking at. So that's one answer, but now we need to find other possible answer. So find other possible B. So again, I take 180 minus the angle I just had to find the supplement, because that is possibly going to be our answer. So I'm going to take 180 minus my last answer, and I get 156.4 degrees. So let's take a look. Okay. So if I am looking at my triangle, okay, just kind of a visual, you don't have to draw this out, but just so you understand, this is 30. This is 156.4, possibly. Well, looking at that together, that is going to be more than 180, right? This is more than 180 degrees, because my 156.4 plus my 30 is going to be equal to 186.4. That means that that particular triangle is not possible. So I have one answer. My answer is 23.6. The second possible B, 156.4, is too big with my 30. Okay, so first situation, we ended up with two totally different triangles. We had two possible angle Bs, both of them working. This situation, we found our first B, we found a possible second B, but it did not make sense. So we have only one possible triangle, so there's only one possible B. Okay, now this example. Again, all of these are side angle. And in all of these, I'm keeping it as a 30 degrees. Okay, I'm keeping this as a 30 degrees. This time, this side is a 7. It had been a 10, it had been a 20, now it's a 7. And again, they're asking us to find angle B. So I want this angle. And this is still 16. That hasn't changed. Okay. So let's set this up. So I'm going to have sine of 30 degrees over 7 is equal to sine of B over 16. I'm going to cross multiply and solve. So I am going to have 7 sine B equals 16 sine of 30 degrees. So sine of B equals 16 sine of 30 degrees divided by 7. And then I want to find my B, which is my angle, so I need to do sine inverse. So I'm going to do sine inverse of this, of 16 sine 30 degrees over 7. So I'm going to put that into my calculator and see what I end up getting. Okay. So in this case, sine inverse of 16 sine 30 over, oops, start again. Sine inverse, I'm going to put it in as a fraction. 16 sine 30 over 7. And I end up getting error. Now, the reason I'm getting error is because your maximum sine, so your sine of an angle is always going to be between 1 and equal to 1 and negative 1. That's where your sine is. So you can't take sine inverse of something bigger than 1 or smaller than negative 1. So if I take a look at this, let me highlight it. If I take a look at this and I put that into my calculator, so I'm going to quit. I'm actually going to do second and enter. And what I'm going to do is this time, I'm going to just get rid of this sine inverse. I'm going to hit delete. And I'm just going to make sure I have my parenthesis. Okay. And hit enter. So I'm just computing what I was taking sine inverse of. And that is an 8/7. This is an 8/7, which is greater than 1. So can't have sine be greater than 1. It's not possible. So when I'm taking sine inverse of something greater than 1, I'm trying to find, hey, what angle gives me a sine greater than 1? Nothing. So this one has no triangle at all. So we had a situation where we had 2 triangles. We had a situation where we had 1 triangle. We have a situation where we have no triangle. So the ambiguous case, you need to be careful. Okay, last idea. This goes back to the very, very first page, the start. Okay, now this is on area of a triangle using sine. So if you're looking at these situations here, and I ask you to find area, first you'd be like, oh, I can find area of a triangle. But then you look and you go, wait a second. I need to have a perpendicular height and base. And I don't know either of those. So I'd have to do a lot of trig to figure that out. I'm not proving these formulas right now. We're just going to accept them. If you have a triangle that is not a right triangle, you do not know your perpendicular height and base. If you know basically side angle side, a side angle side, where you know two sides and an angle in between, you have enough information to solve. So what do I mean by that? So if I'm looking at this particular situation here, I'm going to use that with the first triangle, okay? So let's say we know angle C. If I know angle C, I need to know the two sides that I'm just highlighting that form that angle. I need to know little a and I need to know little b. And then if I know little a and little b and that angle C, I'm going to use that formula. 1/2 side A times side B times sine of angle C, where angle C is in between those two sides. If I have a situation like this one, where this time I know angle B, so I know this angle, I need to know again the two sides that form that angle, which is my A and C this time. And then I would use this formula. If I'm using this one here, where I have 1/2 B times C times sine of A, so I basically know my angle A. So if I know angle A, again, I need to know the sides that make that angle. So I need to know C and B, and then I would use this formula. Okay, so all of these situations are side angle side. So in this case, you'll notice I know my 87. I know this side and I know this side. So you see how I know the two sides that form that angle. So area equals, let me just get a smaller font here. Area equals 1/2 times 21 times 32, okay, the two sides, times sine of 87 degrees. And I'm going to put this into my calculator. So when I put this into my calculator, I'm going to put it in as a 0.5. So 0.5 times 21 times 32 times sine of 87. I end up getting, let's go one number after the decimal, 335.5. That is my area of that triangle. Okay. This one here, again, pay attention to what you know. So in this one, I know this is 123 degrees, so I know that angle. I know this side, and I know this side. So if I know the two sides that form that angle, I can use the formula. So I am going to do area is equal to 1/2 times my two sides that I know, my 150 and my 231, times sine of that angle I know, which is 123. Put that into my calculator. And so I'm going to go 0.5 times 150 times 231 times sine of 123. And I end up getting, okay, with the 0.96, the 6 is 10% up. So I'm going to say that this is about, okay, 14,530. Okay, so hopefully this will help those of us who weren't here today with the notes and understanding how to do the homework. I am posting also a video of the worksheet for tonight, but try to see if you can do it without looking at the video and then refer if you get stuck.